Welcome back. Today we're going to continue our studies in the rational to the real to complex with 2.8 Overcoming Challenges in Factoring. Page 44, please. Opening up our packet to the correct page, we find ourselves looking at some examples of factoring here. Now, it may be useful to list out for ourselves the types of factoring. Number one, you always look for a GCF. Number two is, of course, our special cases. And our special cases are things like difference of squares, like x squared minus 9, or perfect squares, x squared plus 3, 6x plus 9, which is, of course, x plus 3 squared. You may also be familiar with things like the difference of cubes or the sum of cubes, which you've already mentioned before. 3. There is, of course, the classic AM factoring, where the first term has a coefficient of 1, where you look for what adds to the middle term and multiplies to the last term. So it would add to 5 and multiply to 4. And then last and most powerfully, there's factoring by grouping. So looking at our first example, let's zoom on in. Apologies for the quality of the camera there. And focused. There we are. Find all real solutions to the equation x minus 2, x squared minus 6x plus 3, and 2x minus 4x minus 7x equals 0. Now we can actually split that into two problems. We can say, well, I first have to find this solution, and then I would have to find this solution. Well, looking at this, we run through our special cases. There's no GCF. There's no special cases. It does look like an AM factoring, but I don't think there are any factors of 6 that will add to factors of 3 that will add to negative 6. And factoring by grouping does not seem to immediately appeal. So this is a little bit of a curious one for us. Over here, we can also run through our special cases. No GCF, no special cases. It's not AM factoring, and we might have to do some work to get factoring by grouping. So let's see if we can do that. We would need something that adds to negative 4 and is the multiples of the first and the last, so that's negative 14. So what adds to negative 4 and multiplies to negative 14? So that's, we could do 1 and 4, that's not, 1 and 14, that's not going to work. The only thing left is 2 and 7, that's not going to work. And all of a sudden, we found ourselves with two problems that are supposedly factoring problems, but doesn't seem to have an apparent solution. So it's time to bring out the last and final and most powerful technique that always works, which is called completing the square. Completing the square means rewriting a quadratic as a perfect square. So one way to think about that is if I had a perfect square, here's my perfect square, and we had x squared here, and of course these sides would be the same, so we take the middle term and split it, so that's negative 3x, negative 3x. Then this would be an x times an x minus 3 times x minus 3 box, which means the completion of the square would be plus 9. So I can actually go ahead and imagine a plus 9 right here, and since I'm going to be fair to both sides, I'll give the other side a 9 too. This then becomes x minus 3 times x minus 3 plus 3 equals 9. And I've suddenly changed this equation to something that can be solved because x minus 3 squared, take away the 3 from both sides, is going to be equal to 6, which is something I can directly take the square root of. So therefore x minus 3 is going to be equal to plus or minus root 6, or x is equal to plus or minus 3 plus or minus root 6. Now, completing a square does not necessarily mean that the first term has to be a half. It has to be, 1. We can divide everything here by 1/2, if we so care to, and then we're left with 2x squared minus 2x minus 7/2 equals 0. Now to complete this square, this is x squared, break this in half to make it even, x, this is just x plus 1 x plus 1, and that means the completion of the square has to be 1. So I add 1 to both sides. This right here is x minus 1 squared, as we just saw right here. Minus, I'm sorry, I didn't bring the minus with me, and that's on me. I should have been more precise. Minus 7 over 2 equals 1. And therefore, x minus 1 squared will equal, if we add 7 over 2 to both sides, 9 over 2. Take the square root of both sides. X minus 1 equals plus or minus the square root of 9 over 2. Now, we can't leave it in that form because it's, well, bad form. So x has to be equal to 1 plus or minus the square root of 3 times, 3 times the square root of 2. All over 2. The way we get that is by multiplying numerator and denominator by 1 in the form of 2 over 2. And then we get 18 over 4 and simplify, etc. Now, to clarify, our tools are, again, GCF, special cases, AM factoring, add, multiply, factoring by grouping, and completing the square will basically take care of pretty much anything that has a real solution. Yes, there are some that don't have real solutions. Now, taking a look at this quadratic right here, how would we find it? Now, there's no GCF. It's not a special case. We can't say there's AM factoring. Well, we can wonder about factoring by grouping. So if I break this into two groups, like so, then I can have x squared times x plus 3 minus 9 times x plus 3. These have a common factor, x plus 3. Times x squared minus 9. Now, x squared minus 9 is, again, one of our special cases. That's difference of squares. X plus 3 times x minus 3. Therefore, I can set each of these solutions in turn equal to 0. And I get 3. X is equal to 3 twice. Equal to negative 3 twice. And x is equal to 3 once. So therefore, my solution set is negative 3 and 3, with negative 3 having a multiplicity of 2. We're going to continue exploring these in all of these problems here. Now, note in the individual practice, not all expressions and equations below can be factored using the techniques discussed so far. First, determine if it can be factored with real coefficients. If so, factor it. If not, find all the real solutions to the equation. One thing I'd like to invite you to do before you come into class is take 2 minutes right now and decide which technique of factoring you would use for each of these. Then we're going to learn a new technique right here. I'll see you in class. Have a wonderful rest of your day.